If you think about it, if you saw a small wormhole in real life, it would probably look round, like a sphere, maybe a bit like a black hole, but still different. Light from the other side would pass through it, and it would feel like a window showing you a very distant place. When you passed through the hole, the other side would become fully visible, while your old home would slowly disappear inside that glowing spherical window. So, do wormholes actually exist, or are they just some kind of magic disguised as physics and mathematics? If something like that really exists, how do they work, and where could we encounter them? For a large part of human history, we thought space was something very simple, like a big, flat stage where events happen. Even if we removed the planets and stars, something would still remain. That empty stage was space, and no matter what, it existed unchanged forever. Until that moment came, until Einstein's theory of relativity. Einstein said, "This stage is made of space and time, and it is not the same everywhere. The things on the stage, in short, planets, stars, and massive objects, affect the stage itself. They bend it, stretch it, and even reshape it. If the old stage was like a solid wooden floor, Einstein's stage is like a waterbed. When you put something on it, it sinks and quickly changes shape. This flexible spacetime can be bent, maybe even torn and stitched back together, and this might be exactly what makes wormholes possible." I imagine it like this, as if it were two-dimensional. Our universe is like a big, flat sheet. If it is bent in the right way, wormholes could connect two very distant points in the universe with a short bridge. This way, you could almost instantly travel. You could even travel through the universe faster than the speed of light. So where can we find wormholes? For now, only on paper or in our imagination. General relativity says they might be possible, but that does not really mean they exist, because this theory is only a mathematical structure. Of course, it has many different solutions, but as you know, not every mathematical solution describes the real world. So what I mean is, they are theoretically possible, but there are different types. Einstein-Rosen bridges. The first type of wormholes to be theorized were Einstein-Rosen bridges. These see every black hole as a gate opening to a parallel universe. So now let's do this. Again, let's think in two dimensions. Empty spacetime is flat, but objects on it bend it. If you compress that object too much, spacetime bends even more. Eventually, it cannot resist anymore and collapses, forming a black hole. A one-way barrier forms, the event horizon. No matter what you think, everything can enter, but nothing can ever come back out. Everything is dragged toward the singularity at the core. But maybe there is no singularity there. One possibility is that the other side of the event horizon looks like our universe but flipped upside down. There, time flows backward. In our universe, everything falls into the black hole. In that parallel universe, because time flows backward, the black hole spits out harmful and violent matter like a massive explosion. This is called a white hole. But here's the bad news. You cannot pass through Einstein-Rosen bridges. It would take an unimaginable amount of time to cross, and the bridge closes in the middle. So, if you enter a black hole, you cannot become the thing that comes out of a white hole. The only possible outcome is death. Traversable wormholes. If string theory is correct, our universe might already contain many wormholes. After the Big Bang, quantum fluctuations happened at scales even smaller than atoms. During that time, there was a high chance that many tiny wormholes formed. There are cosmic strings passing through these wormholes. In the incredibly short first moment of the universe, the ends of these wormholes might have been thrown light years apart. If wormholes formed in the early universe, they might be scattered everywhere. Maybe they're even closer than we think. From the outside, black holes and wormholes look very similar. That's why some physicists think the supermassive black holes at the centers of galaxies might actually be wormholes. Checking this is hard, but maybe there's another way: making one. Man-made wormholes. A traversable wormhole must have some properties. It must connect distant points, it must not have any event horizon, and it must be large enough not to destroy humans. But the biggest problem is this: keeping the wormhole open. Gravity will try to close it. It will squeeze the bridge and turn it into two black holes. To prevent it, we need to support it with something. And this is where exotic matter comes in. This is nothing like anything we know on Earth or in the universe. It's not even antimatter. It's something completely new with strange properties. Exotic matter also has negative mass. Normal matter, as everyone knows, is attractive. Negative mass is repulsive. It behaves like anti-gravity. This means it would keep the wormhole open. The pressure of this matter would need to be stronger than the center of neutron stars. Maybe we already have a candidate, the vacuum of space. In empty space, particle-antiparticle pairs constantly appear and disappear very quickly. We already use this effect in some experiments. We could use it to stabilize wormholes. After opening a wormhole, the ends start together. Then we could move them to different places. For example, one could stay in Earth's orbit. The other could be sent into deep space. Actually, Earth could become a kind of intergalactic wormhole hub. Yes, it could. But there's a dark side. Wormholes could create paradoxes like time travel, and that's not good. It breaks the causal structure of the universe. That's why some scientists think not only making them, but even their existence might be impossible. For now, the only thing we know is this: wormholes exist in our hearts and in equations.